Did you know the U.S. consumes 20 million barrels of crude oil every day? That is equal to more than 1,250 Olympic-sized swimming pools of crude oil every day. 70% of that, or 890 of those 1,250 pools, are used for transportation fuel alone. It would take Cesar Cilo Filo, the current Olympic gold medalist in the 50-meter freestyle, almost 12 days to swim the length of all of these pools if he maintained his Olympic record pace. The good news is we can decrease the U.S.'s reliance on crude oil by producing and using alternative energy. Some examples are wind, water, and solar energy. But I'm going to focus on the production of fuel ethanol from a process called biomass fermentation. What is fermentation, you ask? Well, that's what I'm here to tell you. That's me in the middle, working with high school students on a science project. My name is Claire Edwards, and I'm a graduate student in Dr. Joy Peterson's lab at the University of Georgia. Basically, we start with plant material, which is made up of a lot of different sugars. Then, add microorganisms that can convert these sugars to ethanol. This process of changing sugars into ethanol is called fermentation. Looks simple, right? It's harder than you might think. There are three main components we have to consider when starting a fermentation: biomass, enzymes, and microorganisms. We'll start by discussing different biomass types. Different types of plants have different kinds of sugars. Woods and grasses have high concentrations of the sugars glucose and xylose, along with lignin, a complex molecule that gives plants structural stability. Lignin cannot be used to produce ethanol, and it actually interferes with its production. There are also fruits, like apples and oranges, that have high concentrations of sugars glucose, arabinose, and pectin. And it gets even more complicated. Plant cell walls are very complex, and the sugars are bound together in long chains. Bacteria are not able to produce ethanol when sugars are arranged in these chains. To break down the sugar chains, we'll have to add enzymes. These enzymes are proteins capable of releasing single sugars from the chains. There are many different types of chains, which means we need many different kinds of enzymes. But that's not all. Just like there are multiple enzymes and multiple types of biomass, there are also multiple types of organisms that can be used to ferment the plant sugar into ethanol. Here's just a sample. Two of the most prominent are Saccharomyces cerevisiae, which is a yeast, like the ones used to make bread, and Escherichia coli, a bacteria found in human intestines. In fact, it's probably inside of you right now. The use of each one of these organisms for fermentation has its own advantages and disadvantages. Yeast is limited in that it can only produce ethanol from a single type of sugar. On the other hand, E. coli, which can use many types of sugars, also produces many different products other than the desired product ethanol. Before we start a fermentation, let's take a quick second to recap what we've covered so far. Fermentations have three different requirements. 1. Biomass. Not all types of plants are equal. Different types have different sugars. 2. Enzymes. A variety of enzymes are required to break down the long chains of sugars into different fermentable sugars. 3. Microorganisms. There are many different organisms that are capable of turning sugars into ethanol, each with its own advantages and disadvantages. Without further ado, let's start fermenting. First, we need a vessel to hold the fermentation, a way to stir a fermentation, and a way to control the heat. What should we add first? The orange? That's right. First, we add our biomass. Now what? Enzymes? You got it. We have to add the enzymes to release the sugars from their chains in the plant. And last but not least, microorganisms. Correct. The microorganisms can now take the sugars released by the enzymes and convert them to ethanol. Depending on how much sugar is present, how many enzymes are added, and the type of organism used, the fermentation process can take anywhere from a few hours to a few days. There is much research being conducted using this method of biomass fermentation to try to decrease the U.S.'s dependence on gasoline. No single biomass, organism, or set of enzymes will hold the answer. Instead, we will need to rely on many different fermentation techniques to produce high enough amounts of ethanol to put a dent in our current crude oil consumption. Now that we have some background, I'd like to tell you a little bit about what I do. My research focuses on a biomass that is rich in pectin and has very low levels of lignin: sugar beet pulp. Sugar beet pulp is the mush left over after sugar beets, seen here, have been industrially processed to produce sugars for foods. Even though a lot of the free sugar has been removed, the sugar that is bound up in the chains is still present. Now let's recall how fermentation works. First, we add enzymes to break up the sugar chains. Then, we add a microorganism, in my case, a bacteria called E. coli. The bacteria will use the sugars to produce ethanol. Unfortunately, the addition of enzymes at the beginning is one of the most expensive parts of making ethanol. That is why I have been researching a method to decrease the amount of enzymes that we have to add at the beginning of the fermentation. One way to do this is by creating an E. coli that can make some of these enzymes itself. Let's see how that will look. We'll start by adding fewer enzymes, which means we'll release fewer sugars. But when we add our microorganism, this new E. coli, it will produce more enzymes and release more sugars from the chains. Therefore, we will get the same amount of ethanol for cheaper. Thanks for your attention.